Hey everyone, today I just want to show you a few review questions for each target for your learning or for your test coming up tomorrow. So take a look at each of these questions. I'll go through them hopefully pretty briefly, I would imagine. And if you have any questions, definitely let me know. You can take a look back at your notes, look back at any old videos, would be definitely helpful. So first thing, talking about irrational numbers. Identify whether each one's rational or irrational and make sure you tell me why. For the square root of 20, that one is a non-perfect square. Remember, like the perfect squares are 1, 4, 9, 16, 25, 36, and so on. Any one of those integer numbers that isn't a perfect square in my list is going to be irrational. So this one's irrational because it's a non-perfect square and you're doing the square root of it. Another way to do it is actually do it on your calculator and you get the square root of 20. Let's see, it should be a little bigger than 4. Square root of 20 is 4.47 and it keeps going on. There's no repeating pattern at all. It just keeps going, and your calculator screen actually can't do all of it, obviously, so it keeps going on, and that's another reason it's irrational. Number 2 is actually rational because it actually ends. It stops after the 2. So this would be 4, 2, 3, 2 over tenths, hundredths, thousandths, 10,000. So it'd be 430 or 4232 over 10,000. And that's actually rational because it can be a fraction. So that's the first or second learning target. Oops, did I skip the first one? Maybe I got confused. Oh, okay, here's the first one. Sorry about that, guys. First learning target. This one is about converting and making sure you can explain why numbers are rational. So this one has one digit repeating. So if it was just 0.4 without the line over it, without the repeating, that'd be 4/10. But this is 0.4 repeating, so it's really 0.444, and that 4 keeps going on. And we talked about in class how this one, if it's one digit repeats, it's just that number over 9. So 4 over 9 is 0.444, just like 3 over 9, or 1/3 is 0.33333. And then for 1/6, you can divide 6 into 1. You can do that on your calculator, but I'll show you here. 6 doesn't go into 1, but 6 goes into 10 once. 1 times 6 is 6, so we subtract that, we get 40, bringing down that 0. And 6 goes into 40 6 times, which is 36. And we see that as we keep bringing these down, 6 goes into 40 6 times, and we get this repeating pattern to happen. So they keep coming down, and it's going to be 0.166, and that 16, the 6 repeats. So it'll be 0.16 repeating. And let's go back to the next one there. Fourth one, approximating integers. So this is learning target number 4. And basically this is just saying, if you didn't use a calculator, do you know what the square root of 90 is closest to on a number line? Okay. So, we know a bunch of different things about different numbers here, and so on. But square root of 90, we want to think of some perfect squares that are close to it. So I know that the one below it would be the square root of 81, and the one above it would be the square root of 100. So by this logic, since the square root of 81 is smaller than the square root of 90, and then the square root of 90 is smaller than the square root of 100, and we know these guys on the ends, we know the square root of 81 is 9, and the square root of 100 is 10, the square root of 90 is some integer, or some number between 9 and 10. And this one's actually pretty close to the middle, but this is a difference of 9, and this is a difference of 10. So it'd be just a little bit closer to 9, a little bit less than 9.5. So if you can show in that reasoning there, that's what we're looking for. Next question. Ordering numbers and placing them on a number line. So here if you have to put them on a number line, you can get the calculator approximations of each of these. Square root of 82 is 9.055. Square root of 68, 8.25 if I round a little bit. Careful of exactly what you have to round. But these would be actually almost in order. This is the biggest one. So 99 over 10 would be there, because we want them in order from, oh, what does this say? It just says in order, so we'll do least to greatest, I guess. So we got this one taken care of. Then we have square root of 82, go a little bit smaller there. Then it'd be 8.9, and then the last one, square root of 68. So that would be in order. Next one. Now we're getting into some of the Pythagorean Theorem things. So this one's about a proof here. Can you explain a proof of the Pythagorean Theorem? And we've seen this example, and I just kind of want to show you one more time basically what you have to prove. Sorry, this is going to be a little ugly here. Let's try this again. What you have to prove is that this larger square on the hypotenuse of your right triangle, and let me show you what the right triangle actually is. It's this guy right here. So you have to prove that the larger square, that blue square, can be made up of areas of the smaller squares. So the other two smaller squares we're looking at are this red square, and we'll call it, let's do dark green, this square right here. So if we can count up the areas in the red and green squares, they have to completely fill the blue one. So let's count red. We have 1, 2, 3, 4 boxes there. So we can actually fill in 4 of these boxes, I guess, if we want to do it that way. And for green, we'll count that up. We have 1, 2, 3, 4, 5, 6, 7, 8. Obviously you'll see here there are 16 as you're going around here. So we can then fill in basically 16 of those. So we have 1, 2, 3, 4, 5, 6, 7, 8 whole boxes there. So we still need 8 more in here. And now when we do each of these triangles here, here's one triangle. This triangle has a base of 2 and a height of 1. So 1/2 base times height gives me 1/2 times 2 times 1. And half times 2 times 1 is actually 1. Wait, did I do that right? Yeah, sorry, I was just thinking here. So that means each of these triangles around the outside are all 1. So we already had 1, 2, 3, 4, 5, 6, 7, 8. And then this triangle would be 9. This next triangle would be 10, 11, 12, 13, 14, 15, and 16. So 16, and then the 4, sorry, I was thinking in my head there, and then the 4 red dots, 16 plus 4 does give us that area of 20. Okay, so once again, the 4 plus 16 is 20 idea there. Okay, and to clean this up one more time, just to make sure it kind of makes a little bit more sense, hopefully, you can kind of see now, if you can look at my original work there, that each of those triangle areas was an additional 1 unit. So on the inside we had a total of, it's kind of cross-looking thing, 12, 13, 14, 15, 16, 17, 18, 19, 20. So one more time, that's how that worked there. Another proof you can think about for these would be this guy right here. This is another different type of proof of the Pythagorean Theorem, and here's how this one works. For this one, what you can think about is the outside areas of each of these red squares are exactly the same. And if we subtract out equal sized pieces, the area is still going to remain the same. So if I take out one triangle of these dimensions from each side, and again, these triangles right here that I just drew are actually the same areas. So we started with the red areas equal. If we take out a black triangle, they're still equal. We take out another triangle from each side, they're still equal. Take out another triangle from each side, they're still equal. Still the same areas. Take out another triangle from each side, they're still equal areas. So here what we're left with is a squared, b squared, that's what's left over in the left one, And what's left over in the right one is c squared. I shouldn't have done that in green, sorry. But that'll work. So what this means is that here a squared plus b squared is what's left over, and over here c squared is what's left over, so those have to be the same. Next topic here, we'll look at a few Pythagorean Theorem things. Here you guys are doing pretty well with setting up these overall. Make sure you always look for the hypotenuse, and it's always across from the right angle, because these pictures could be rotated around many different ways. So to set this one up, it would be x squared plus 12 squared. Those are the legs, and it has to equal 13 squared. I'm not going to solve that one because you guys are doing pretty well with them, but if you need to, you can go ahead and do that one. The answer there should be 5 for x. And this one, to set it up here, the hypotenuse is what we don't know. So this would be 12 squared plus 12 squared should equal h squared. A lot of us get into the habit, or some of us get into the habit of always putting the two numbers first, but we don't want to actually do that. It's always depending on what that hypotenuse is. If the hypotenuse is a number, then it goes the number on the right hand side. If the hypotenuse is a variable, it goes the variable on the right hand side. Okay, next up here. On the coordinate plane, to find the distance, this is target number 8. You just have to make sure you plot your points. So negative 1, 2, 3, 4, negative 1, 2, 3, 4, 5 would be right there. And 3, 4 would be right here. So to find the distance, we can use the Pythagorean theorem. You can go up and over, or you could have gone over and up too if you wanted to. Okay, but anyway, when you do that, you create a right triangle. And this black segment will be the length of our distance. So simply count how many squares are here, and how many squares, or how many distance, what's the distance of that one there? It's 1, 2, 3, 4, 5, 6, 7. And this is 1, 2, 3, 4, 5, 6, 7, 8, 9. So to do the distance here, you do 9 squared plus 7 squared, and see what that is. That'll be your distance. I don't have the, let me see if I can figure out the answer real quick. 9 squared and 7 squared would be 130 when you add them together, and the square root of 130 is 11.4. So you should get a distance of 11.4. And just to check, it actually is the largest side. It's larger than 9 and 7, and that's the case. That's what it should be. Alright, distance, or determining if they form a right triangle. So what we would do here is we have to think about this as the Pythagorean theorem and see if it would work out. So first thing you got to do is go through and identify which one's the longest side. If this is a right triangle, that would be your C. So that's going to be your hypotenuse if it's a right triangle. And then we want to do the legs, the smaller ones, and square them. So when we do all this math here to see if it works, again, we're not sure if it actually works out to be a right triangle. So we want to kind of put a question mark here maybe. 30 squared is 900. 41 squared is not one I have memorized. 1681. And 52 squared is 2704. So we want to see if these are equal to each other. When we add 900 and 1681, we get 2581 and 2704. Since these are not equal to each other, this is not a right triangle. If they were equal to each other at the end there, then it would be a right triangle. Okay, last review question here is about a word problem. And I'm just going to kind of draw a picture and set this one up. A school bus must travel 6 miles west and 8 miles north to its second stop. It travels the shortest distance back to school. So if you start in one spot here, your school bus is going 6 miles west. So that would be 6. Picks up a kid here. Okay, and then they go north from there. And they go 8 miles north. Pick up another kid, and then they head right back to school in the shortest distance. So to figure out this distance, it would be the square root of, well, what we would do to set it up would be 8 squared plus 6 squared, and I think you should get 10 after that. 8 squared plus 6 squared equals d squared. When you do the math there, I believe you do get 10 for d. And then it wants to know the total distance, so you'd actually have to add up all three sides. So 6 plus 8 plus 10 would be 24 miles. Okay? Thanks for listening. Let me know if you have any questions. Good luck, guys, tomorrow.